Morning to everyone.
Good morning.
So from deep learning, let us move to the free environment. I'll take you to the region where you don't have to use mobile. If someone uses mobile now, they will replace me. So with that understanding, let me start my journey with all of you. So it's about 45 minutes. What I will do is, first I will take you to the environment where I work. Then how we visualize the same environment through the computers, through GIS, spatial analysis, and then what we can do, how it helps in decision making. And also I will make a comment whether it has been used by the decision makers of 21st century. Okay, how effective is these technologies? Well, this is the environment I work, the Western Ghats. In fact, this is my home from Kerala to Gujarat. So all of you have small apartment, but I have a bigger area. Now, my environment is free. I don't even have to use a mobile. Communication comes to me. I don't have to do the deep meditation also to understand the patterns in the system. All happen simultaneously. Now, this is a region has to be conserved. That's what we say. And why we have to conserve that, let us try to understand. When you look at the relationship between number of species and occurrence of the latitudinal gradient, you will see that the Western Ghats from Kerala to Gujarat is range from 8 degree to 22 degree latitude. Okay. Now when you look at the number of species, 8 to 14 degrees has the highest number of species. Highest number of species in terms of plants and animals. That means we have diversity of animals and diversity of plants. When you have diverse animals and plants, you have diverse food and also the medicine. And what medicines we have today is only the 5% of the plant what we have described so far. So that means still 95% has not been detected, and there is a lot of opportunity for the youngsters to understand that. That is where the spatial data helps. So you will know that where that particular the species occurs, what kind of habitat it occurs. Okay. And this is what the estimate is, 9 to 12 million species globally. On the earth you have this many species. So that means there are a lot of opportunities for the youngsters to take this idea forward. Now, when you look at the nature, nature is in balance as long as the two-legged animal is not there. The day when the two-legged animal get into the system, you have the problem. Now, when you look at the nature carefully, you will learn the science. You know, the laws of thermodynamics you can understand by just looking at this. The energy transfer happens, energy optimization happens. So now the second thing is the remediation, the treatment happens. You would have seen people washing clothes in rivers, and then you see that after 500 meters, when you collect the water sample, you will see that there is no contamination. That means the water, as it moves from point A to point B, the treatment has happened. That is called remediation. It is done by the organism. Like algae, that is why it's called bioremediation. That is another hottest topic we study. Okay. Then the third is the sustainability. You know, renewability is a part of the nature. The younger ones come, the elder ones plays out in the system. So that's how we sustain the resources, including the humans. Okay. So now to manage this kind of the ecosystem, you need to have ecosystem approach. So you need to understand the physical and chemical integrity of the system. That will ensure the biological integrity. Biological integrity, I talked about it, the number of species that occurs. It will occur in a particular location. You cannot bring those species and put them in Bengaluru. It won't work. It will not have the medicinal properties. So that means we need to ensure the physical integrity of the system. That is where the spatial analysis helps. Now, let us understand how we do this. We have the spatial data. The remote sensing data are available. Satellites we have launched way back in 70s. Every 21 or 30 days interval you get the data. That means a huge amount of data is available at varied resolutions, the varied spectral, spatial, radiometric resolution, and so with the temporal resolution. That means you have a lot of data to analyze, but only the thing is you need to know how to analyze that. Okay, that's what we have done for this region. And let's go to the district where we have spent almost 2 decades, the Uttar Kannada district. See, this is the administrative boundary of the region. As an ecology, for me, agroclimatic zones and the kind of the natural resources that are there matters to me. Now, when you look at this, this has a 3 agroclimatic zones: the coastal, then you have the hilly terrain, Sahyadri, and this is a plain, and then these are the river network. When you look at my district, the district is full of water. The district is full of water because there is a lot of vegetation there. The region where the vegetation is missing, people are struggling for water. Whether you go to the arid region, if you look at 100 years back, when vegetation was there, people had water, but today they have lost it. Okay, now let us start the spatial analysis. See, when we take up a river basin, when we take a river, we study the entire basin or the entire catchment of the watershed. This is where our polygon or the vector data analysis we start. Okay, these are the major river basins in the region, and these are the other data layers. These are all available today. SRTM data is available at 90 meter, and today even 30 meter data is available. You can generate the slope, and also you can link that with the drainage network. Okay. Now, how do we analyze the remote sensing data? I am sure the earlier speakers would have talked about it. Just for the completion of my talk, I will touch upon that. We use the supervised classifier, maximum value classifier. Of course, my students have worked on developing various algorithms. One of my student, earlier student, is the faculty here in IIIT. He might touch upon the unmixing algorithm, etc. Now, coming to the remote sensing data, we have the bands of data. We generate a first color composite which helps us in identifying heterogeneous patches. Now we need to find out what is heterogeneous patches. This is where the training data is collected from the field. Now, when you do the remote sensing data, you will see the heterogeneity, but you do not know what they are. Now, what I will do is, since this image is a georeferenced image, I'll just load that polygon details into the GPS, and I go to the field, and when I go near that particular polygon, it beeps, then I find out whether it's agriculture or a horticulture or a forest or an open area. That's how I collect the training data. Then I come back, use the Gaussian maximum likelihood classifier, I do the classification, and our accuracy is as high as 85 to 90% because this is supervised classifiers. Okay, this is how we collect the data. Now, in addition to that, for analyzing the biodiversity, we have a grid-based analysis. We divide the district into 9 km by 9 km and select the representative grids, and then go to those grids and do the detailed mapping of plants and animals, etc. See, when we take up, we do the mapping of plants, we find out what is the biomass, and you can see my team working, and also we collect the data related to the water, and then come back to the lab and extrapolate for the entire district. That's how we use the remote sensing data, and also we use some collateral data like French Institute, vegetation maps, etc. Okay, this is a standard protocol we follow. So you know the administrative boundary, then you have the remote sensing data. Today you have a temporal data, you can analyze all of them. You have the simple technique of Gaussian maximum likelihood classifier. So you can do the land use analysis, and you can do it at temporal scale, then you can find the changes that is happening in the system. Okay, now this is the outcome of the temporal data analysis from 1973 to 2018, what's happening. Okay, now this is the power of GIS. The visualization is the power of GIS. So you can find out what changes are happening, where it is happening, etc. Now let us try to visualize this. This is in 1973. You can see the entire district have a vegetation cover, the forest cover, and this district has the distinction of having highest forest cover in the country to an extent of 80%. If there are changes are happening in the district, then that is something quite worrying also. Then now let us look at what does the next time data shows. 1979, you see the forest cover has come down to 75%. You can see these are the places we lost the forest. It could be because of the various developmental project or because of the human habitations, etc. Then in 89, you see the reservoir has come, with that we lost the forest, and here some teak plantations have come, with that changes have started happening. 99, then 2010, 2013, and this is 2018. When you look at from 2018 back to 73, you see that currently you have the forest only in this region, you have lost the forest here. So in a district which is supposed to be conserved, to be protected, we are seeing the degradation happening. Degradation to an extent of, see, if you look at the evergreen forest, which is of 67%, today is about 29%. So now that shows, that reveals what changes are happening. If we didn't have the spatial data, probably we wouldn't have been able to tell what changes are happening, where it is happening, and why it is happening. Okay. Now these are the things helps in modeling. See, so that you can visualize and say that what is likely to happen in 2025 or 2030. Okay. Now we see that the forests are getting fragmented. We can also analyze the fragmentation, the extent of fragmentation. There are various levels of fragmentation. You know, perforation, then fragmentation, then the dissection. Like this, we have various indices. Now, why the fragmentation is important? Let us take this example. See the animals which are residing here. For that animal, the entire region is its territory. Now, when there are agricultural land appears in the region, naturally, animal as they move from this region to this region, they see a different crop, they just taste it. When they taste it, the farmer senses the loss of crop. So what he will start doing is, he will start hunting or the shooting. Now when he starts hunting or shooting the animal population senses the danger. When they senses the danger, they stop moving out. They start residing in a smaller pocket and then they breed among themselves. This phenomenon is called inbreeding. Now with the inbreeding, you will see that population becomes weaker. Why it becomes weaker? Because there is no exchange of gene. Earlier, the animal from here would have exchanged the gene here. Now, today, because it is within the family, the cousins, so there is no exchange of gene. Naturally, you will see that gene becomes a weaker one, and finally it leads to the extinction of the species or the rooting out of the species. So now, if you are talking about the conserving the tiger or any animal, you need to understand what is its territory and then protect that territory. That is where spatial analysis helps. Now, this also helps in you addressing the problem of human-animal conflict. You would have seen in some location there are human-animal conflicts. Now, these are all the regions where the fragmentation happens, the human-animal conflicts happens. Now, remote sensing data helps in that. So what we do is we compute PF and PFF. PF gives the proportion of the number of forest pixels to the total number of non-water pixels in a kernel. We take a 5 by 5 kernel, that means 5 pixel by 5 pixel kernel, and analyze PF. Similarly, we compute PFF. Once we have PF and PFF, we know the extent of the forest and the type of the forest, quality of the forest. If PF is 1, everything is forest, that's why the ratio is 1. That is the intact forest. If PF is less than 0.4, it gives the patch forest. Intermediate, the values show the levels of degradation. Now, we computed the level of fragmentation using PF and PFF. All these publications are available online. You can download that also. Now, this gives you the extent of the fragmentation. You can see the contiguous forests are here, but you see that it's a patch or the fragmented forests are on this. Now, from 1973 to 89, you see the level of fragmentation that has happened in the system. 2018, you can see that it is almost, you see that we have lost the contiguity of the forest. So that's where it affects the ecology of the region and also the water sustenance in the region. Okay, we also predicted what is likely to happen with this kind of changes. We said that, so that is another thing. We use the agent-based modeling to predict that. I will not get into the mathematics of that, so because of the time constraint. Okay, now let us also understand what is the worth of forest. See, one of the things when I rub my shoulders with the bureaucrats, first question comes to me is what is the worth? Why do we have to conserve it? For them, we did the quantification. We said that what are the benefit people get in the form of timber, fuel wood, and non-timber forest producers like spices, etc. We quantified that and multiplied by the market price. We know that in a patch of forest, how much resources are available, what is the worth of that. So this is the quantification we have done. For all the 11 taluks, there are 11 taluks in the district, and there are, you see the Q is the quantity and P is the price. So in each taluk, J is the, I is the number of taluks, J is the type of the product. Suppose if you have a timber, you have tea, rosewood, jungle wood, etc. You can spatially analyze the location of the tea, jungle wood, etc. So you know the spatial extent, you also know the yield. At the other end, how much is extracted also you know, and the price of that. With that, you know that what is the worth of the timber. Like this, all this product you will quantify, and aggregation of that will tell you what is the worth of the forest. Now, when we did this for Uttar Kannada district, we were surprised. The value is as high as 9,282 crores per year. This is a recurring thing. Every year we get 9,282 crores from the goods like timber, LTFE, etc. Now, if I take the scenario 2, if I add the wild fruit, the worth increases by another 20%. If I add oxygen, we all know that the trees give oxygen except the Bengalurians, so that which will add to another 19%, so it's about 15,000 crores. So now this is the scenario, or this is the worth of the forest. Now if you look at the GDP, I don't know who invented the GDP, that doesn't account into the natural resources, the degradation of natural resources. The GDP of this district is 5,182 crores. In that, only 120 crores is accounted toward the forest resources. When the bureaucrat does the quantification, they say 120 crores, but when the researcher does it, it shows 9,000 to 15,000 crores. That means that much money is filtered in our system because of lack of the data and also quantification. That is where GIS helps. Okay. So now let us understand why we need forest. Because I was told that everyone requires water. So if they require water, then we need the forest. So now the type of the forest, we look at how the quality of the forest, whether it has any relationship with the water and natural resources, we are trying to understand. Okay. Now this is what happened during my time. You know, when I was a student, I used to enjoy the water. Today when I go that in the same location, I don't have the water. So that means there is something to do with the forest in the vicinity. So let us try to understand it through the science. Okay. Now I'll take you to the region, my district. These are the 4 river basins, the drainage network. This gives you the annual rainfall pattern. You see some region, this is the high rainfall, there is the lower rainfall. You just link this with the vegetation cover in the region. You will try to see that wherever the vegetation is very good, the rainfall is also very good. Wherever people have degraded the region, so you see the rainfall is also scanty. That means the first understanding is that there is some linkage between the vegetation and the rainfall. Now let us try to understand the kind of land use in each river basin. See, because the remote sensing data is available, you can do the temporal data analysis. You know that how things are changing in the river basin. This helps in the planning and decision making for the people who want to serve the country. There are many people who do not want. They want to loot and take away the resources. For them, this data is not required. And unfortunately, today we have them with a large proportion, okay, in the system. Now let us try to understand the water availability in the system. See, these are the regions. You see there are water is available all 12 months. These are the regions where water scarcity is there. Now when you look at wherever forests are there, you see it allows the water to infiltrate, and whatever infiltrated water in the system comes to the river or a stream during the lean season. That's how the streams maintain the continuity of the water. To put it in simpler word, wherever streams are there, the streams with the native species, the vegetation in its catchment, higher than 60% cover, those streams carry water all 12 months. Wherever people have converted the native forest into monoculture plantation, which covers more than 60% of the catchment, then you know the water sustenance in the stream is the 6 to 8 months. That means we have lost 4 to 6 months of water. And wherever people have degraded the forest and it has become a barren area, the water is available only during the 4 months, that is during the monsoon. Now we analyzed the livelihood option with the water availability. Wherever forests are there, you see enough water is stored in the underlying layer which can meet the societal demand. Wherever forests are not there, you see societal demand is higher, but there is not enough water is infiltrated. You know, that is where the scarcity happened. So in fact, you know, the civil engineers in our country looked at the Western literature. They said that the forest has no role in the water sustenance. For the first time, we proved them wrong. Okay, and of course that is where our research started, being discussed at various levels, even at the international forum. For the first time, we showed wherever forests are there, we have water all 12 months. Where forests are degraded, you don't have the water all 12 months. And also it gets reflected in the livelihood of the people. Now you take a village which is in the close proximity of the forest, which has a native vegetation. Take another cluster of villages where the monoculture plantation, rubber plantation and the eucalyptus is there. You analyze the livelihood option. Our study shows the people who are in the villages in the vicinity of native forest, they earn per year per acre 1,54,000. While the people who are in the vicinity of monoculture plantation, they earn only 32,000 rupees per acre per year. Now if you look at how that rubber plantation has come, people talked about development. One fellow became a big man by growing the rubber, but the villagers in that area lost 1,54,000 minus 32,000, around 1,22,000 per acre per year lost it. This is how, when we degrade the natural resources, it affects everyone. Okay, but benefits one fellow or the group of people. Now those group of people are vocal. That's how they always say that country has to develop, but country has to develop at what cost? Not depriving our children their water. They have the right to have a clean and adequate water, but that is what is being hit in our country today. Okay, now you can see the spatial analysis, the power of that. You see wherever forests are contiguous, you see the perenniality is there. Wherever it is fragmented or they degraded, you see that you do not have the water all the 12 months. And also rainfall follows the same pattern as the fall. In fact, we did the study for a small river basin. This is about 10 years back. Then now one of my students did it for the entire Uttar Kannada district. Okay, so we brought out the link, and this article is getting published in the current science. More probably in the February or March issue it will be published. Okay, now let's look at how the biodiversity we document. See, as I said earlier, the district we divide into 5 minutes by 5 minutes split, or 9 km by 9 km. And also you recall the district had 3 agroclimatic zones. We will choose the grid in such a way it represents all the agroclimatic zones, and also the adequate samples we have taken. When we take this grid, each grid is 9 km by 9 km, which is 81 square kilometer or 8,100 hectares. It's a quite huge area. You cannot go to 8,100 hectares and do the documentation on that. It will take 1 year. So what we do is a sampling. We lay a transect based quadrant. In this transect, we have 20 meter by 20 meter quadrant. Then within that 5 meter by 5 meter, and then 1 meter by 1 meter, the 4 are there. This 1 meter by 1 meter, we sample grasses and herbs. Then the 5 meter by 5 meter, we sample the shrubs. Shrubs are the small plants which are height less than 1 meter. Then 20 meter by 20 meter, they map the trees, which have the height higher than 1.5 meters and other more than the 30 centimeter. That's how the trees, shrubs are distinguished. Now we have accounted the trees, herbs and shrubs. Then we leave a gap of 20 meter and put another quadrant. How long will it continue? As long as we go on getting the new species. That means, suppose if I get 20 tree species here, if I get 22, I will continue the journey. The moment I get in another quadrant 22, I will stop the thing. That means I have reached the saturation. There is no need to put in the extra effort. Like this, we do the analysis, and we have covered about 156 transect in the district. Now these are the agroclimatic zone. You can see the grids, and also this gives the type of vegetation. Evergreen, the deciduous, marsh deciduous, like that. So we have chosen the grids in such a way to represent the agroclimatic zones. Okay. Then we have done the transect based quadrant. These are the plants which we have mapped, and this is the animal that is mapped. This is a team of about 22 people worked with me for about 2 years to do this whole exercise. So temporal data, the remote sensing data, satellite passes through in a few seconds, and you have the picture. You can see the status. But when you want to know the further details, you need to do this kind of detailed analysis. Okay. Now I want to see which are the regions which are ecologically sensitive. Now what I do is, all these spatial layers I'll aggregate, I'll prioritize, I'll rank it and aggregate that. Then whichever has got the higher this one, we say that those are the candidates for conservation. See, these are the variables I have considered for the aggregation: land, ecology, geoclimate, hydrology. I showed all those layers. Then we assign the weightage for each of the things. If it has got a good forest cover, greater than 80%, we give the rank of 10. If it is degraded, it is 2. Like that we have done, and this gives the status of the ecology of the region. When you aggregate it, whichever grid gets the higher, you will say ecologically sensitive region 1, 2, 3, 4. This is how the weightages are assigned. This is available in the publication, which is available online. You can go to ResearchGate or Google Scholar. You can download this document. They are available freely. Okay. Now this is how the weightage is given. Now each of the things. See, now forest cover. You see that greater than 80%, we have assigned 10 for the grids where the forest cover is more than. And the grid less than 20, we have assigned the rank of 1. So now you know the variation in the forest cover. Similarly, you have the plants, which are great. We found the endemic species, we have assigned the higher rank, and then depending on the species proportion, we have graded they differently. Okay, then fauna, then rainfall, which are the rainfall wherever is higher, we have given the higher ranking. Okay, now then the hydrology, wherever 12 months water is available, it gets 10. Wherever 8 months, then the 8, then the 6, and then 4. Okay, then the energy, then we have wind and bioenergy, then the social aspect. This is very important. Wherever the tribal populations are there, that grade we have assigned in, because they are the one who conserve the forest, not the people in Bangalore or in Delhi. So now I aggregate all these layers, whichever has the higher weightage, we say that is the region, ecologically sensitive region 1. This is sensitive region 2, this is sensitive region 3, and this is sensitive region 4. Now when you look at the Western Ghats, it constitutes only 5% of the country's land area, geographical area. And the ecologically sensitive region, what we have mapped for the entire Western Ghats, constitutes only 40% of the 5%, that is about the 2% of the entire thing. I think the country has to understand one thing. When we have Western Ghats with the water, the rivers, 100 plus rivers in the Western Ghats, the water security is ensured. When there is a water security, there is a food security for the peninsular India. If you are talking about peninsular India, the food security and water security, one has to conserve the Western Ghats. Okay. Now, this kind of analysis will help in prioritizing the region based on the eco-sensitiveness. Okay. Then we know that which are the grids, and also we overlay the panchayat layers. See, these are the boundaries of the panchayat, and you know that which panchayat has the eco-sensitive region 1. Now, as per the Biodiversity Act, each panchayat is supposed to have biodiversity management committees. Now, when you provide this kind of the information, they can take a call on the project. Whether the project can be allowed or not allowed, they can take a call on that. That is where the decision support system helps. That's what we did that. We developed a decision support system which is available online, so that the panchayat president or a panchayat member can just access their village and find out why it is ecologically sensitive region 1 or the 4 or the what kind of activity can happen. That's where the decision making or the planning of the region it helps. Now you understood there is a linkage in the ecosystem. Everything is connected if we respect the ecosystem. Everything is disconnected if we have a fragmented ideas in our brain. Okay. Now let me bring you to the Bangalore. The way I spent some time in Bangalore, I'll also show you what is happening in the Bangalore. We use the temporal remote sensing data. Again, the same protocol we follow for analyzing and visualization. Agent-based this one. We use these are all the publications are available online also. So now this is a standard protocol for modeling to visualize what is likely to happen in 2020 or 2025. We have done that. This is about 3 years back. So now when you look at Bangalore, look at the way the data gives you the information. Wherever I have shown these images, people have got started worrying. You know, when you look at Bangalore, the current Bangalore is 740 square kilometer. In this 740 square kilometer, way back in 1800, we had 1,452 water bodies and 80% green cover. Today in the same region, the 193 water bodies. Our elders had created the interconnected water bodies to meet the irrigation and domestic water requirement of the region. Whereas today our leaders have swallowed this water body for their benefit, talking about development of the country and making GDP 8.5, 9.5, all kinds of tamashas are happening in the system. When you look at the Bangalore is a small hill. You have the water flowing in the 3 directions. That is where we have 3 watersheds. We have famous Bengaluru and Vartur lakes also. Okay. Now look at the way the Bangalore has changed. You know, 68% green cover in 1973, 7.97% is red, which are building. Now when you look at 2019, 81% is red and 3% is green. As per the norm, we are supposed to have 33% green cover. What we have today is only 3%. See, that is also quite worrying. This one that is affecting the health of the people as well as the, you know, in this city there is oxygen deficiency. There are people use oxygen cylinder in the midnight. The people who are in the age group of 55 to plus who have respiratory problem, in the night they run the oxygen cylinder. The region which had oxygen surplus, we have taken it to the deficiency. So now this gives the location of the water bodies and also the water bodies which we have lost. In fact, we have the distinction of sending a chief minister to the jail because of the GIS. So you can go back to this one. When we did the analysis and presented it to the court has also made that person to spend 3 days in the jail. That is the power of GIS. The people who commit sin will have to go to the jail. Okay. The same thing happened in the Bellary. Using using the quick bird data, we showed how the illegalities in the mining sector is happening. When I was in the committee, I insisted that we should go for the higher spatial and spectral resolution data, and when we did it, we could find out how these people were cheating the system by the earlier cadastral map manipulated and all those things. The land is somewhere else, they go on extracting, they would have got the permission for 5 hectares, they would have extracted 500 hectares. When we showed that map, Supreme Court sent one minister for a year in the jail. Okay. So now the Bangalore, if this trend continues, 94% of landscape will be concretized by this year and 98.5% would be concretized by 2025. The children of Bangalore, the tomorrow, will see only the high-rise building. They think that the city means the tall building should be there with the senseless human being occupying that. Don't worry about the children, that kind of thing happens. Okay. Now let us see what is the modeling we did. This is 2020. You say 93% is the thing. That is where I wrote an article saying Bangalore is becoming unlivable. Almost all the paper the media carried it in the front page and both print and electronic media. But whenever I interacted with the youngsters of today, go to the college or the university, none of them knew what is happening to Bangalore. Then I was talking to my students. One of my students told me, "Sir, don't worry. Conveying the message to them is very easy because most of the time they close their eyes in the classroom. But when we put in another area where they are active, I will take them there." So he just posted in the Facebook. All these faceless fellows woke up. They started phoning me to find out, "My God, Bangalore is dying, what should I do? How do I say the thing?" I told my student, "Don't worry, another 3-4 days I will receive this phone call. After 4 days, they will also go to the same place where they were earlier." See that today's youngsters spend most of the time in killing the time using the mobile. We created the technology, the mobile, but we should not have become the slaves. As a technocrat, we have no right to become a slave. We should use our knowledge and intelligence for developing other thing which will solve the problem of the society. But what I see is that people use more mobile, don't sleep, and during the working hour they sleep. So this is the problem. Okay. Now let me take you to the concluding part of my talk, the Western Ghats. We showed to the world what is the worth of the Western Ghats. This is the very latest publication that has come out using the remote sensing data. One of my students, Dr. Bharat, is here. As a part of his doctoral work, he did this. Okay. Now we quantified what is the carbon stored in the forest and what is the land use. So in this one currently and 2031, and also we said that what is the biomass and also carbon stored. When you see the tree, you will see a trunk. You find out how much is the carbon stored there. In the 2-time period, you will know that how much per year also it is getting stored. We did that quantification. This is incremental carbon per year. Now, then we also projected for 2031 what is the likely scenario with this level of degradation, etc. Okay. Then we also link that with the climatic parameter, the temperature and the rainfall. We see there is a linkage. 1 to 1.5 degrees increase in temperature is happening wherever people have removed the vegetation. The people without hair on the head, their head gets hot. Exactly, the landscape also has the same thing. When you put water on their head, I'm not telling to you, sir, please don't forget. So, see, when you put water on their head, water will float out. Whereas when you put it on the head where the hair is there, it takes some time to flow. That is what the landscape, when it is covered with vegetation, that is the thing. People should remember this by that, okay? Wherever you see the landscape without the vegetation, that is as good as of course, we have made the Prime Minister of the country also, one person who had a similar head, okay? So now, to the concluding part, there is a decline of evergreen forest by 5% during 85 to 2080. And if you look at the worth of the Western Ghats, carbon stored, it works account to the 100 billion rupees, which is 1.7 billion or 1.4 billion dollars. Our colonial system or the earlier development happened. the industries, the countries become industrialized. They emitted a lot of carbon. Those carbons were taken away by the forest in our country. We need to tell those fellows, because of you, okay, we have removed the carbon, you give the equivalent compensation. That kind of argument can happen in the international forum only when you have this kind of data. That is where the spatial analysis helps. Okay. Now, I'll also take up another 10 minutes. Is that this is the concluding part. I'll give 5 minutes to tell. In addition to that, as a researcher, what we are doing. Okay. So one is whatever we have learned, we take it to the youngsters. So I have a network of schools and colleges in Karnataka and other part. About 40 institutions are there. We also organize a symposium popularly known as Lake Symposium. This I have been doing from 98. Uniqueness of this event is that even year we do it, is the school children come and take part in this program, the 4 days event, and one day they do the presentation. We also give the orientation program for them, how to do the experiment, etc. You know, when people go to the mall in the weekend, my students go to the school. That is the beauty of my student. That's how they contribute to the nation. That is how we are helping the nation. Okay, and if possible, you can create a new lake. That is another thing. And plant native sapling. You might ask, okay, your preaching is fine, but what you preach, are you practicing? See, this is the water body I have created in the Iisc campus, 2008. Okay, when I proposed, some of my colleagues said it will become mosquito, this one breeding ground. At that time, I told them, mosquito will be there where humans are there. Where nature is there, mosquitoes are not there. We know how to control it. Today, you come and spend here, you don't see the mosquito there. Okay, and also students, when they get agitated, they go to this pond and enjoy. Recreation happens. And today, I have these animals also. The otter, we do not know from where it has come, but it is residing there. We do not give them a food, nature gives the food. That is where 2 of my students analyze the biodiversity in the pond. You see this 2005, you can see me taking a measurement. 2008 onwards, the different year how it looks. This is the algae, this is zooplankton, this is the fish and the bird. Okay, now you have otter and also you have a lot of snakes in the region. So you can enjoy the environment there. So in fact, one of my students got me the skin of the snake. We asked him to measure because we always believe in the metric, measure, then say that. And then when he said that it is 279 centimeters, we asked him to find out the same species, what is the maximum length reported in the country. When that is an innocent question asked to the student, when he did the literature review, he came back and told me that the maximum length is 240 centimeters. So the youngsters who are here, you are in the campus or adjacent to the campus, Indian Institute of Science. We are #1 in country. We are #1 because of our student, and also not only the student excel, even the animals in the campus excel. So that is the thing. You leave some cat there, when it comes out of this gate, you will see it become a jnani. So you see the behavior starts changing. Okay, but of course there are people who come to this campus, sleep and go. In their career, there is not much change happens in the system. Okay, now when I meet people, I'll make them think. This gentleman met me about in 2016, that is the period the Mudbidre was facing severe water crisis. So, and just then we had talked about steel flyover, beda, that kind of thing, and my talk had become popular. When I was in Bengaluru, the media carried my travel plan. At that time, he came to know that I am in Bengaluru. Then he fixed an appointment with me, and we met in the night. So then he said, I have 12 acres of land. I told my student, the golden opportunity. We just prepared a document. We did next day the field survey to find out where the lowest point. Because wherever we go, we carry the gadgets, including our brain. Okay, which is very important. So we did the topography survey and also rainfall analysis. We found out what is the water available, where is the lowest point, what should be the size of the thing. We gave the proposal to him in 2016 May month. Within 10 days, he implements the thing. When I look at this success, and also he takes up the planting in the catchment. And when I look at the success of this, because of the youth, he is here. And also the people who are involved are from the Alva Science and Engineering College. The success is the youth. See, people when they cross 32, they start talking all fancy ideas. 25 to 32 is the golden period in anybody's life. They can contribute to the system. Yeah, rather 20 to 32. Then after that, you know what happens. Like in the TV debates in the late evening, you would have seen that. Okay. Now you see the success is because of this man, and also we made sure that he also take up the rejuvenation of the lake. Couple of lakes he took up, 2 lakes as the symbol of the thing. I told him that if you touch 2 lakes, I will have a success in this taluk. So the moment he did 2 lake rejuvenation recently, because the Swamiji did, the people in the local area, they took up the rejuvenation of the remaining 30. And this year there was a water, the drought was there, but that taluk didn't face the water crisis, while the neighboring Mangaluru had the water scarcity. This is where, you know, I'm a firm believer. Science, society, culture and spirituality has to go hand in hand. So what I can communicate, these people can communicate to thousands of people. You know, I can at most can communicate to 1,000, but these people do it to lakhs. So that is the beauty of that. When they do it, we make people sensible and responsible. That is what our motto is. Then I saw the success is here because of this young man. He is the CEO of Allwas because he gave the financial result. Then next year, what we did is, in his college, the water body of 25 lakh liters. And he took up the planting of native species. Again, we gave, my colleague Harish Bhatt gave this on what kind of species to be planted. And when we visited 2018, you can see there's a smile in our face, and also the water in the background with the greenery there. And you should understand, those who are in this right age, when this initiative was taken up, this man was alone. And recently when I went, he had got a partner. The people don't have to go to the Facebook searching for the product which is not available to them. So the best product they will get the moment they do this kind of nature solutions. Okay, that's another message for the youngsters who are looking for a prospective right partner. It could be a male or it could be female. But today there's a gender equity, so that way each one can do something for the society. Okay, this kind of thing we discussed. That is where the forum of Lake Symposium, and you see children, we do the orientation program, and we go to the schools. That's where the weekends happen. Then we do the small experiment, make sure that school campus has at least one sapling planted when we are there. Okay, the children do the carbon sequestration, they do the GIS analysis. You know, here the children are measuring the location, girth and height. Okay, then they, you know, wherever lakes are there, catchment analysis, they do it through the GPS. They map the thing, they collect the water sample. I have taken GIS, GPS, remote sensing to the class 6 and 7 in Bengaluru and in Karnataka. You know, that is what we have done. And if we do that, next level of the GIS expert will be much superior than my generation. Okay, so then these are the kids have been trained to collect the sample. They collect the sample, they come to our lab, they analyze. Then those who are in the campus would have seen this, the climber. This, I was fascinated by the architecture. When I was a student of the Iisc, I just said I should have it in Bengaluru, that is in my campus. I brought that pot to the Bengaluru. I planted in 7 places in the campus. One other place next to my building has become this one. Now, when you look at this pot, what I got is here. There are 14 seeds. Out of 14, 7 are in my lab. Still, 7 I planted in 7 locations. But when I planted, I was a student. I didn't know that I will continue in the campus. Like most of the people will not know. But this fellow knew that I will continue in the campus, that too in this building. So that is the beauty of the nature. The nature keeps track of us. If you think that nature is not observing, you can throw the litter below the thing, you know, the next day you will have a problem at home. Okay. Now, in front of this building, we created a mini forest. You know, I have 4 families of this, and this gives a glimpse of the mini forest. This is again the age group of 20 to 32. You know, that is what happened. When we were students, we have done remarkable thing. Of course, that helped us in continuing further. Now, what is the beauty of this? The groundwater table at that time, when the region was infested with Parthenium, groundwater table was 150 feet. Today, the groundwater table is 5 to 10 feet. Use the remote sensing data thermal sensor. You will see the temperature in this region is another 2 degrees lower. Okay, and you have varieties of the fauna. The snakes, birds, everything is there. We respect each other. That's why they don't trouble us and we don't trouble them. So that's how the nation has to be. That's how the region has to be. Okay, those who want more detail can go to this website. I have been pushing the open source GIS. I don't like the commercial thing. That is where I can take the GIS to the schools and colleges at no cost. Today, remote sensing data is available in public domain. You know, most of the studies are zero cost. Only my student time is the thing. So what you saw, the Western Ghats, the entire thing we have done at zero cost. We use the grass and QGIS. So I want the open source to become more and more popular. When more and more youngsters do it, they can also develop the algorithm, put it in the public domain so that everyone can use it. The deep learning can also happen, even the communication can become more effective in that, okay? Now, we also do the capacity building at various things. This is the 16th session on environmental management. Every year we are doing it during September to December. This is the last batch we did it. And, you know, these are the areas. And if you want the detail, you can go to this website. You can write to me. If you remember my name, do the Google search. If you don't remember, then you don't have to worry about it. Okay? So, if you remember, then if you pose any question, I would be happy to answer. Now, when you look at my web page, the group web page, it looks like this. You see that research paper sections and also our initiatives are there. You know, water testing labs were not there in many schools. Today, I have created water testing labs in the 7 or 8 institutions out of the money which I got as award, etc. So that way, the money which comes to me for the recognition of our work, I don't take it home. So everyone has accepted, my students have accepted, and my family has accepted. That's what we are doing to the society. And if you see the research paper section here, you see all the papers in PDF format is available. You can go through see if you are interested in remote sensing GIS, you can go to this. Uttam's work, Sudhira's work, all is available. So, and also related to the lakes in Bengaluru, you know, you have the details available online, okay? We have done a good job. I would say the credit should go to this team, which is young. When young fellows work, they will keep smile on our faces. Thank you very much. So,